Welcome again to this channel. This is G Solutions, where we present solutions for your needs. So we are now on the capacitors. Present to you here the capacitors in series and in parallel or combinations. By the way, we are using the symbol, a straight line and a curve. That is the symbol for our device because capacitor stored electrical charges. So it has two plates, this one and the other one, and it is separated by an insulating material which we call the dielectric. So in this case, all the positive charges are here, the straight line, and the negative is here. Since that it is store charges, it has an electric potential. So C sub 1 can have a value for that, an E1. And C sub 1 also has a charge 1. So also this one, plus, minus, the positive charge and the negative charge. So it will be creating an electric potential, let's say E2. And the charge at C sub 2 is Q sub 2. For C sub N, this is your positive and this is your negative. We use here N for variable, which means that you can add more capacitors in series with C sub 1 and C sub 2. So you have also here value for your potential, which is E sub 1 at charge Q sub N. If it is connected in series, the behavior of the capacitances here, if you are going to get the summation of all the capacitances that is connected in series, it is just the inverse proportional. I will use here C sub T, which is for my total capacitance, and equivalent to the inverse capacitance of capacitor 1, which is C sub 1, plus the inverse capacitance of capacitor 2, and also the inverse capacitance of N. So for you to get C sub T, this is the opposite of the resistor. When you connect a resistor in series, you just add everything, but here we take the inverse proportional of the capacitances and equals to the inverse capacitance of the total capacitance, or the capacitance equivalent, which is in a resistor that will be a parallel connected resistors. So it is quite the opposite of resistor. So when you connect again a capacitor in series, you take it as a resistor that is connected in parallel. Okay, so that's it. So this is the behavior for the capacitances. Now for your charges, all of the charges, if you are going to get the total charges of all of these capacitors, the total charges of all of that is equal to the individual charges of capacitor 1, which is Q1, also equal to the Q2, and also equal to Qn. And for the electric potential or the voltage, so the total voltage for a series capacitor is the summation of all the voltages of each of the capacitor. So that's it. How about if you are going to connect the capacitor in parallel? Okay, so this is the parallel connected capacitor. Parallel capacitor is, if you want to get the summation of this parallel connected capacitor, it will be likened to resistor that is connected in series. By the way, this is your positive and this is your negative, and you have here also, since it will develop a potential, it should have an E1, and this is your charge 1. Also with this one, this is positive, negative. It has a potential of E2. This is Q sub 2, and also this one, plus, minus. This is E sub N and Q sub N. Okay. What is the total capacitance of parallel connected capacitors, E sub T? Just simply add the capacitances C1, C2 plus Cn, or so on and so forth. And for the charges, total charges is actually the addition of individual charges of each of the capacitors. So Q sub 1 plus Q sub 2 plus Q sub N. And for the voltage, E sub T is the electrical potential of each of the capacitor is equal. E sub 1 is equals to E sub 2 is equals to E sub N. This is the behavior of capacitors in series and in parallel. So, thank you.